Hello friends, welcome to this channel. This is G Solutions. We find solutions for your needs. If in case you encounter this kind of problem with a capacitance, which is 35 microfarad, is in parallel with a certain element, and you are to identify this element and also find the value of this element. Given that the voltage across the circuits has a value of 150 sine 3000 t, and also the total current of 16.5 sine 3000 t plus 72.4. Okay, so we are again to get the value of this element and what kind of element is this. So let us try to figure out. Suppose you have this figure and there is a capacitor here. Again, this is 35 microfarad. Okay, so we are to have this element in parallel with this capacitor. We don't know the type of element is this, and we don't know also the value of this element, so we just put here say prime. There is a current that flows, which is I sub t, the total current, and also a voltage in this point, which is the B. You have here a value which is 150. Now, to be able for us to solve for Z prime, let us first get the total impedance of this system. And to be able for us to get the ZT, or the total impedance of the system, we can use the total voltage and the total current. So we have the B sub t and I sub t. So to be able for us to get the B sub t, which is 150 sine 3000 t, we make this 150 as an RMS values because this is in peak value. So to be able for you to make that in RMS value or effective value, you divide that to square root of 2. So also with the current, this is the peak value 16.5, divide it by square root of 2. Okay, the angle of your voltage is 0, so you don't see any angle here, but your current has a value of 72.4, this one. So this is 72.4 degree. Okay, notice that the square root of 2 will be cancelled out, and 150 divided by 16.5 will give us 9.09 with an angle of negative 72.4 degree. Since that this is in the denominator, it will be placed into the numerator, so the sign will change. So this is now your ZT. Let us solve for Z prime in a way that we will use the concept of the inverse of your impedance and the inverse of your resistance and also the inverse of your reactance. For the inverse of our impedance, this is actually the admittance. So the admittance is YT. For the total admittance, this is actually the inverse of your total impedance. Okay, so we already have the value of your total impedance, which is 9.09. This is of negative 72.4 degree. Okay, and if you are going to get the inverse of 9.09, it will give you 0.11. This is of, so this will become positive 72.4 degree. Because this is in the denominator, it will become a numerator. Or you can have the rectangular form of 0.11, cis of 72.4, which is 0.033, and the other part is plus J 0.1048 or 10.5. This is in ohms, and this is now in mho or in Siemens. So you'll notice that this 0.33 is actually the inverse of your resistance. This is now your conductance, and this one is the inverse of your reactance, which is your susceptance. Okay, now let us solve for Z prime. Solving for Z prime, actually y sub t, and let us get the value of this one in admittance form. So that will become 1 over Z prime plus 1 over, we have here J x sub c, or can be written as y prime plus 1 over Jx sub c. Okay, so that's it. We equate this to the value of 0.3033 plus J 0.105. Okay, so this is y prime plus, now if we are going to place J to the numerator, it will become negative because we will multiply here J times J, and J squared on the denominator is negative 1. So this will become negative J, over x sub c. Okay, let us try to solve the value of x sub c. So what is x sub c? X sub c is equals to 1 over, actually this is omega c. Actually x sub c here is a negative value since this is a capacitor. So this will be negative omega c. So that is 1 over omega. Negative omega is given here 3000. So that is our value for omega, 3000, and also 35 microfarad is changed to farad. So this is 35 times 10 to the negative 6. It becomes now farad. Now if you are going to use your calculator, 3000 times 35 times raised to the negative 6, it becomes 1 over negative 0.105. Okay, so that is the value of your x sub c. Now let us again write the equation plus J 0.105. Okay, so equals, so this is now y prime. I write here negative J and over, so the value of x sub c is 1 over negative 0.105. So that's the value. So therefore becomes y prime here. So this becomes positive, and you divide this by negative 1 over negative 1.05 by 1. Result is 0.105, and this is positive J. So you'll notice that 0.033 plus J 0.105 is equated. So therefore we can say that this value is equal to this value, and therefore y prime is equals to 0.033. So therefore we say that y prime is equals to 0.033, and if we are going to get the impedance value of your y prime, that will be the inverse of Z prime, so that is equals to 30.3 ohms. So this is the value for the elements parallel to 35 microfarad. Okay, so therefore this element is actually identified as a resistor. Okay. So this is how you solve the problem. So thank you for watching this video. I hope that you learned something from this video, and please subscribe if you are not yet subscribed in this channel. Also share this video to your friends. Thank you.